Hot take. Your embedding model is probably not the thing hurting retrieval. Your chunks are.
Yes. Teams swap models, tune vector indexes, and add re-rankers when the real failure happened earlier. They fed the model text in a shape that hides meaning instead of exposing it.
Shape is the loaded word there. People hear embeddings and think, just turn text into numbers. Why would the shape of the input matter that much?
Because embeddings do not encode facts in isolation. They encode the meaning of a span of text as presented. The same information, broken differently, gets represented differently. Boundaries change what is emphasized, what gets diluted, and what relationships survive.
So, this is not about chunking as a housekeeping step. This is about deciding what semantic object the model is even allowed to see.
Exactly. If a chunk mixes a rule, an exception, a table heading, and half of the next section, the vector represents that mess. It does not know which part you wanted to preserve as the retrieval unit.
Give me a practical case, not theory.
Imagine internal API docs. One section defines rate limits. The next section explains retry behavior. If you chunk every 800 tokens with blind overlap, you might create one chunk where the end of rate limits is glued to the start of retries. A query about backoff policy retrieves a chunk dominated by quota language. The answer looks plausible, but the retrieved evidence is off-center.
And that is the dangerous version of failure. Not no result, wrong result with confidence.
Right. In RAG, a near miss can be worse than a miss. A miss can trigger fallback behavior. A near miss slips into generation and contaminates the answer.
Let us get specific on chunk size. People always ask for the magic number. 200 tokens, 500, 1000. What is the real trade-off?
Small chunks improve focus. They often map to one idea, one procedure, one definition. That helps retrieval precision. But too small, and you amputate context. So the vector loses what the statement is about. Large chunks preserve context, but they blend multiple intents, and the embedding becomes an average of competing signals.
Average of competing signals is the phrase. So bigger is not richer. Bigger can be blurrier.
Exactly. Think of a chunk as the unit of semantic compression. If you ask one vector to stand in for 3 different topics, it cannot fully represent all 3 at once. The strongest or most repeated language wins, and the quieter but crucial detail gets buried.
Concrete scenario number 2.
Take a runbook for incident response. There is a section called Database Failover, with prerequisites, trigger conditions, and a rollback note at the end. If you slice it too small, the rollback note might become a lonely chunk that says, revert traffic only after replication lag normalizes. On its own, that chunk may retrieve for random lag questions, but not for failover questions, because the parent procedure context is gone.
So, too small creates orphan facts. Too large creates semantic soup.
That is the balancing act. Good chunks are not just short enough. They are structurally coherent. They should match how the source actually organizes meaning. A procedure, a policy clause, a function docstring with parameters, a single FAQ pair, a subsection with one job.
You slipped in structure, which feels more important than size.
Often it is. Size is a blunt control. Structure is the smarter one. Headers, lists, code blocks, tables, and step boundaries tell you where meaning starts and ends. If you ignore that and cut by token count alone, you produce chunks that look valid to software, but invalid to semantics.
And then someone says, fine, I will buy a better embedding model.
A stronger model helps at the margins. It cannot rescue a chunk that combines unrelated material or strips away the local context that makes a statement interpretable. The model only sees the text you pass in. It cannot infer the missing header you cut off or unmix 2 topics you merged.
That is the power shift, then. People think model quality dominates, but upstream representation decides the game.
Yes. If your retrieval units are badly shaped, the expensive model just gives you high-quality embeddings of bad units. Precision does not emerge from semantic confusion.
One more example. Something engineers can picture immediately.
Think about code-based documentation for a payment service. There is a function reference, then a long note on idempotency keys, then examples in 3 languages. If you keep the whole section together, queries about the Java example may retrieve the idempotency discussion, because that concept dominates the text. If you split the examples away from the note, but keep each example attached to the exact function and parameter context, retrieval becomes much cleaner for implementation questions.
So, the winner is not the team with the fanciest vector database. It is the team that chooses retrieval units aligned with the job the user is asking the system to do.
Correct. Chunk for the likely query and answer path. If the task is procedural, preserve steps. If it is reference lookup, preserve the definition with its scope. If it is policy, keep the rule with its exception. That is how you protect meaning before the model ever computes a vector.
Which means chunking is really interface design for the embedding model.
That is a good way to say it. You are deciding what counts as one thought. Get that right, and embeddings become useful signals. Get it wrong, and retrieval becomes a lottery with very polished infrastructure around it.
And the strategic consequence is brutal. Bad chunks waste everything downstream. Better models, re-ranking, prompt tricks, all of it is compensating for a broken unit of meaning.
Exactly. In RAG, you do not retrieve documents. You retrieve decisions you made about document shape. Choose the shape well, and the system gets smarter. Choose it badly, and no model can save you.